Hello, my name is Laura Schwartz. I am from IBM TJ Watson Research Center, and today I'll present paper FIXME, Enhanced Software Reliability with Hybrid Approaches in Cloud. With the promise of reliability, cloud become ever popular. So the question is how one supported, how SREs or system reliability engineers can support it. So in this paper, we talk about various data sources, talk about how work with patterns enabled given the large data sets, talk about hybrid diagnosis approaches, of course, continuous learning with feedback, and finally, evaluation of the proposed approaches and implemented approaches. Contemporary microservices architecture has simplified software development, but it made a very difficult job of SRE or IT operations. The main goal of SREs or system reliabilities engineers is problem determination, diagnosis, and resolution based on the symptoms that environment or hybrid architecture provides. The most difficult part based on the interactions with SRE is actually to localize the problem and to diagnose the problem. There is a number of approaches, analytics that target to help SREs. Typically, they focus on a specific data type like events or logs and so on. And the successful approaches, now there is a trend to apply these existing approaches to different data types, and it has its challenges and benefits. On this slide, you see the data types that we're working with, or IT operations working with. Worth to mention that events are something of a notification of something happening. Alert is a notification of something happening that requires an attention. There is also incident and change records, which are sort of self-explanatory. Also, if we look at the logs and metrics, logs are events also which describe what happens essentially at the point of time. It's an event. Now, metric is a measurement, and metric is usually taking at a point of time in certain intervals. We also work, and obviously logs and metrics can reflect the latency, traffic errors, and saturation of the system. We also work with virtual topology in the cloud. So in the cloud system, a physical node is virtualized to run multiple virtual VMs. Each VM is virtualized to run multiple containers. There's also a virtualized network that provides virtual interfaces that support overlay and hybrid protocols. Overall system has represented as a graph. You can see an example. It has nodes and edges. Nodes, you can see here essentially the boxes are there are 52 type of nodes, and in the table here you can see which ones, and there are 41 edge types. That represent the cloud topology. We also work with the data. Our data doesn't necessarily comes in a way that it's easy to process. Consider that events templates, log templates created by different system, by different people. So the data that it contains varies largely. And in order to understand this data, we have different methods. We apply different methods. So for example, for logs generated, we apply templatization. So our log template pipeline consists of two components: error classification and templatization of a log line. The outcome of this error classifier is subset of total log lines, which then input into the next step of the pipeline template miner. A template miner is pre-trained in the system, that pre-trained on millions of logs lines, and it is used then to obtain corresponding template ID from a running log, then getting this template ID separate log lines to generate pipeline with enriched sets of template IDs. We also obviously normalize the data. In monitoring, for example, it's not uncommon for a large hybrid application to have a variety of monitoring tools, which will create different format or different even type of events. So normalization, obviously, part.
Let's talk about methodology that is used. First, entity resolution. The challenge with alerts often comes from the fact that they created from manually defined templates. And so how they identify the resources depends on the local standard where the template are defined. To allow embedded information to be used for locating the resources, we have defined matcher language. Matcher language allows a user to describe how the locations embedded in the raw alert object. We also use dictionary-based approach. We scan the definitions for look-like references. Specifically, we use information we know how it looks like DNS, number of names used by Docker images, Kubernetes objects, and so on. We combine the names with the regular expressions, and that allows us to identify the embeddings. To adapt to the changing environments, we have internal query system which compiles, allows us to compile rapid regular expression. So the other challenge, the second challenge is now in identifications that used in alerts. We use UUID, Kubernetes has object IDs, their IP addresses, DNS names, and that creates again a challenge. We have a rule files that allows us to get value that should be identified for the topology. Keep in mind that for each topological search, we need to make sure that the time information is accurate because of so many changes in the topology. Learning patterns. Obviously, the alerts comes together. They come together in the known patterns because they identify known problems. So it's important to understand the groups of alerts. We use association rule mining, which consists of two steps. The frequent item set mining, when we identified all alerts that often come together. And then the rule generation, when we generate rules from those. We also look at the law or create log templates. Each application consists of several microservices forming a graph. If one service fails, potentially the services that downstream or upstream from this particular service will also have problem, will also have a log file. Then again, we're looking at the correlation of these different log files or the log lines to collate them and to create what we call log signature for a particular event or particular issue. For each log signature, we also identify similarity, or for multiple log signatures, we identify similarity. We also look at use word embeddings. Natural language processing techniques help us understand the patterns within the events. We apply fast text word embedding to the alert description to train the embedding model. Later, this model turn alert descriptions into learned representations. In order to identify how the embedding is clustered, we apply Birch to the embeddings.
Okay, hello again, everyone. We are here with the author of our third paper for this session, Monitoring Cloud-Based Services. And the author is Larissa Schwartz, one of the authors. Unfortunately, Larissa is having a problem of blocking her camera, so she cannot appear face-to-face, but we have a nice picture of Larissa here, and she can hear everything we say and will be able to answer questions as they appear on the chat. So let's wait a little bit, Larissa, and see if the audience start adding questions. Meanwhile, perhaps while we wait, I'll ask you a question. What you intend to do as next steps for your work, an application for your work?
Hear me, Andrea?
You share the screen? Yes.
No, that's okay. I guess I wanted to make sure you can hear me. So it seems.
Oh, yes, I can hear you. Yes.
Yeah. So part of this work is already in the product. That's a product that supports IT operations, or SREs, which are system reliability engineers. And we continue, from research perspective, we continue to expand to the hybrid cloud. A lot of what you see in the paper actually targets a new modernized development microservices running on the cloud and on the containers. But from the business perspective, from the enterprise's perspective, most applications are hybrid. They have a cloud element or cloud native part of it, but they also have something that we call legacy. And so we need to be able to expand to address, to provide additional capabilities, address what's unique in the legacy portion. So that's one of the areas of research that we work on now.
Okay, thank you.
Thank you.
Let's see if more questions are coming. You mentioned before the backstage that you wanted to clarify some issues about evaluation. Or
sorry.
just you mentioned before that will be an opportunity to discuss some issues about the evaluation of your approach. Do you want to elaborate a little bit on that now?
Yeah, sure. I can do that. So if you can share the slides.
Okay, let's try. No, is this one? I hope people can see it.
Yes, it's I can see.
Okay, which slide would you like me to go?
I think it's slide 7.
Okay. All right.
Yes. Yeah. Thank you. So this slide talks about evaluation and experimental setup that we had. You can see that it's a fairly extensive. We have large data set from the cloud, from the IBM cloud, and we have applied the methodology that discussed in the paper to really sufficient, I guess, number of alerts. You can see it's 1 month identified 382 issues which are grouped, right? And then there were a lot of, so the groups were actually 141, and there is still a single alert issues, right? We worked with our SREs, so they validate what we suggest, and the information that feedback that we received was positive. You can see the extent of topology for the application, which is massive. So we're lucky to have access to this team that has big responsibilities. And if we go to the next slide, please, Andrea.
Yeah.
Thank you. That's where the results actually, I'm trying to find, yeah, I don't know if everybody can see.
Apparently, yes. Yes, people from the audience said that they can see.
Okay, it's small, but nevertheless, I want to point out that so this one shows is a hybrid correlation. As you've seen in the paper or in the presentation, we use a combination. We use temporal and spatial methods. We use association, rule mining, and log template grouping. And what you can see in a table, table 3, is how these three methods provide the similarity and dissimilarity, right? For each one of them, you can see results there. I'm not going to read it, and I think the point is again that each of this method provides different. Each of this method maybe works well, or not maybe works well for specific type of data, right? And then combination of the methods allows us to achieve good results overall. So maybe one of the things that I also want to mention is that the goal is to combine, before we start processing or reason over the operational data, we combine the data together. Log anomalies, events, metrics, and so on. And then we start reasoning. That allows us to achieve better results. And as you can see on this chart, right? I don't want to describe the charts. And if we go to next slide, please.
Yes?
Yes. So this is about, this slide talks about essentially feedback, right? As the application is dynamic. Changes to the applications, it doesn't matter at what level, is it infrastructure level, if it's platform level, but the changes are massive. And so we need to be able to adapt. One of the ways to adapt to in time is actually to use feedback that SREs provide. Now, the point for us was here, or the goal for us here, was to build capabilities for SREs to provide feedback quickly, because they have their job, which is stressful, and the time, I guess, it's really important within the certain period of to have their response within a period of time. So their feedback was limited to yes, no. Now, if you think about capabilities like correlation, yes, no meaning thumbs up, thumbs down, right? If you think about correlation or grouping, thumbs up, thumbs down doesn't give you all the information that you want to validate your correlation, for example. So nevertheless, we were able to implement methodology that was able to take into account this thumbs up, thumbs down, and use it to adjust our grouping, our correlation. And you can see results here. So I think that was interesting work, and seems that our SREs appreciate ability to provide feedback quickly, and the fact that system can learn from it immediately.
Okay, thank you. I'll stop sharing now in case there are some questions coming, and remind the audience again that there is a discussion room that Larissa will be there in case people would like to follow up with any other questions or anything else about her presentation and her work. Okay. Thank you, Larissa.